Hello friends, I welcome you in lecture number 12 on higher order partial differential equations. In this lecture we are going to discuss another shortcut method for special right hand side. So far we have seen shortcut methods when right hand side is either exponential function or sine or cosine function. Today we are going to discuss shortcut method when right hand side function is a polynomial function in x and y, that is, if each term of right hand side function is in powers of x and y. If f of xy has every term in this form, then we are going to apply today's method. So we are going to discuss how to find out particular integral when each term of right hand side function is in the form x raised to m times y raised to n, where m and n are positive integers or natural numbers. So if each term of fxy is of the form x raised to m y raised to n, then we expand 1 over f d dash, that we can write as minus 1 power of f d dash. We will expand this f d dash raised to minus 1 in an infinite series of ascending powers of capital D or d dash using binomial theorem and then operate on the right hand side function fxy term by term. So this we will understand with the help of example, but before going for the method we just recall the binomial theorem. So binomial theorem is a representation of this type of function 1 plus something raised to alpha, where alpha is any real number. So using binomial theorem we can represent or rewrite this function as an infinite series, and that series is given by 1 plus alpha x plus alpha times alpha minus 1 over 2 factorial x square plus alpha minus 1 alpha minus 2 divided by 3 factorial x cube and so on. And if we take alpha equal to minus 1 in this formula, we will obtain 1 over 1 plus x, and by taking alpha equal to minus 1 on the right hand side we will obtain this series. So whenever we have 1 over 1 plus x, we can directly use this formula. It is alternating series and in increasing powers of x, 1 minus x plus x square minus x cube. And if we replace x by minus x everywhere in this equation, we will have this representation of 1 over 1 minus x. So whenever I have 1 over 1 minus x, I will write it as an infinite series in powers of x, and each term is positive here. So we will keep in mind these three formulas that we will require, and if powers are minus 1 and 1, we can directly use these two formulas. Now we understand how this method works. So here I have taken one example. Find a particular integral of this non-homogeneous equation in which our function on the right hand side is polynomial function in x and y. We can see that each term of this function is in powers of x and y. So here we are just asked to find out particular integral. So we will not go for complementary function. We will directly write down particular integral. So here z can be written as 1 over d square minus d dash operated on the right hand side function, which is 2y minus x square. So here now I have to write an infinite series for this expression 1 over d square minus d dash. So to apply binomial theorem we require 1 plus something to the power alpha, or we can apply this 1 over 1 plus x or 1 over 1 minus x. So first we write this expression in this form 1 plus something. So for that we can take minus d dash common. If I take minus d dash common, then we can see here I will have 1 and this d square divided by d dash. So we are rewriting this d square minus d dash in the form 1 over 1 minus x by taking this minus d dash common, and we can verify. If we multiply this bracket by minus d dash, then I have minus d dash, negative negative positive, d dash will cancel out and we have d square. So this is correct. We can rewrite d square minus d dash in this form. So now you can see I have written, let me rewrite here. This is 1 divided by 1 minus d square divided by d dash operated on 2y minus x square. So now we can observe that this 1 over 1 minus d square by d dash, it looks like this, 1 over 1 minus x, and we know that this we can write in an infinite series as 1 plus x square and so on. Every term is positive and increasing power of x. So this we have to apply here. Instead of x we have d square over d dash. So we replace x by d square over d dash in this series on the right hand side. So now we are applying binomial theorem. We are writing this in an infinite powers of d and d dash. So now I am writing this 1 plus, instead of x I have d square over d dash. Then in the next step I have to take square of d square over d dash, and this will continue, and right hand side is 2y minus x square. Now here be careful, we are having infinite number of terms in this series, and we know that this capital D stands for derivative with respect to x. So here I have d square, that is 2 times derivative with respect to x, and here I have d square square, that is 4 times derivative with respect to x. Now if I differentiate this with respect to x single time, then I will have first derivative of this with respect to x will be 0 minus 2x, and second derivative will be minus 2, and third derivative will become 0. So derivative, all the derivatives after third derivative with respect to x of this function are 0. So it is not necessary to write this term also, because here we will have d to the power 4. So that is fourth order partial derivative with respect to x of this function, that is going to be 0. So the non-zero terms will be from first and second term of this series only. If we apply the terms of this series from this term, then we will have 0. So that is very important thing, that how many terms of this series are having fruitful contribution, or how many terms are giving us non-zero values. We have to write down only those terms. If we are writing this, then that is fine, no problem, but we must be sure that after which term the values will become 0. So first I am applying this one on the right hand side, that is 2y minus x square, and here I am applying d single time. D square can be written as d into d, and d means partial derivative of this function with respect to x. So I am differentiating with respect to x single time, and I will have minus 2x, and in the next step I will have d raised to 4, that is 4 times partial derivative of this with respect to x, that will become 0. So from this term all the terms become 0 and series becomes finite. Okay, again I repeat, first we apply 1, that is 1 into 2y minus x square. This d square by d dash I have written as d by d dash into d, and I am operating only this part d, that is partial derivative of this function with respect to x. So y is constant, so 0 minus derivative of x square is minus 2x, and here we have d to the power 4 in the numerator, that is fourth order derivative of this function with respect to x, that becomes 0. Now we again keep this as it is, and first we write 2y minus x square plus 1 over d dash, and again I am operating this d on this function, that is derivative of this with respect to x, which is minus 2. Now we know that d dash stands for derivative with respect to y, so 1 over d dash stands for integral with respect to y, and minus 2 is constant, and here we have 1 over d dash operated on 1, that is integral of 1 with respect to y, and that is y. So here I will have minus 2y. Now this is minus 1 over d dash, here we can cancel out this 2y minus 2y 0, and I have minus x square, and negative negative positive, and I will have 1 over d dash, that I have to operate on x square. 1 over d dash means integration with respect to y, and we are integrating partially, so x square is constant, integral of dy is y. So this is now free from capital D and d dash, that means that is our particular integral. So particular integral is nothing but x square times y. So this is also another easy shortcut method, and this method is applicable when right hand side has every term in this form, or right hand side is a polynomial function in two variables x and y. And to apply this method, first we have to apply binomial theorem. For that we have to write our function capital F of d and d dash in this form, 1 plus something raised to alpha, and we can observe whether it is possible to write either in the form 1 over 1 minus x or 1 over 1 plus x. So here it is possible to write this as 1 over 1 minus something, and then we have applied that series. This series is applied by considering x equal to d square over d dash, and then we operate the terms one by one to the function on the right hand side, and we find that after which terms series becomes finite, or after which term derivatives becomes 0. So this is all about this session. In upcoming lectures we will discuss 2 more problems of this method, that is shortcut method when right hand side is a polynomial function of x and y. So I stop here. Thanks for watching.